we're going to take a look at sigma notation right now. If you're coming from 3 Advanced, I know you spent some time on this. I'm not sure how much. If you're coming from regular 3, we did not see this at all. It's one of those things where it's not a difficult concept, but the notation is new. So once you figure out how to read the notation, usually this goes pretty smoothly. First, I'm going to start off with sigma is Greek letters. You might remember from our statistics unit, we had a lowercase sigma, which was for standard deviation, and we've also got an uppercase sigma. Both of these are the letter sigma. You have the lowercase, which is for standard deviation, and you have the uppercase, which is just a shorthand for addition. So for example, suppose I had a list of numbers, and that list of numbers started at 5, and I was just adding every number, 6, 7, 8, all the way up to 100. And if I wanted to write out all those numbers, it would take quite a bit of work. But I can shorthand that, and I can rewrite this statement as the following. Uppercase sigma, I'm going to just pick a variable. In this case, I'm going to choose n, and I'm going to say that I'm going to start at 5, and I'm going to end at 100, and I'm adding up n. This piece right here in yellow functionally says the exact same thing as that list of numbers. In fact, I can even take it a step further and find the actual sum, which I don't know off the top of my head, but there are some shortcuts we can use to find that. The trick when we're looking at sigma notation is this. This bottom piece right here tells you 2 pieces of information. It tells you your variable, which usually is either going to be n, I, j, or k. Technically, it can be any variable because you just pick the letter or symbol that you want, but traditionally it's going to be one of these 4. So that's kind of what you have to look for, n, I, j, or k. This number right here, the 5, tells you where to start. And the way it works for sigma notation is I'm going to plug in every integer after I start until I plug in the integer where I stop. So we're going to take a look at a few of these, and I pulled all 3 of these practice problems from the actual assignment. So the first one we're going to take a look at is this one right here. Let me make sure I'm on the screen. Yep. And it says the following. We've got sigma n equals 4 to 7, and I'm plugging in 3 in. Okay? So what that means is this. I start with 4. I plug 4 in for n, and that's going to give me 3 times 4, and that's my first term. I need to do that again, but now I'm going to plug in 5. So I take now 5, plug it in, I'm going to have 3 times 5. I do that again, but now I plug in 6, so 3 times 6. I do that again, so now I plug in 7, 3 times 7. That's my stop number, so now I stop. This is the sum being described by this sigma or summation notation. If I do a little simplifying, 3 times 4 is 12. 3 times 5 is 15, 18, and 21. If I add those together, 12 and 18 is 30, plus 36 gives me a final answer of 66. Assuming I did that right, please tell me if I didn't, because I am not imperfect. And that's all there is to it. You take your starting value, you plug it in, you get that term. You plug in each consecutive integer until you get to your stop value, and then at that point you just add them all up and you're done. Let's take a look at another one. Next one we'll look at right now, we've got I equals 0 to 3, and we're going to plug into -6 plus 3i. Yes, For some of you, that looks like that imaginary number, but in this case for sigma notation, the I is just telling us what variable to plug in. And it is important to check. We might not see very many of these, but in higher levels of math, there may be instances where you've got more than one variable in this, and so rather than ending with just a number, you might end with an expression that has variables still in your answer. So I'm going to do the same thing I did up above, where I'm going to take the 0 and plug it in. So my first term, I've got -6 plus 3 times 0. My next term, I'm now plugging in 1, so I've got -6 plus 3 times 1. Next term, I've got -6 plus 3 times 2. And then my next term, I've got -6 plus 3 times 3. So I'm going to take a moment and just do all of this arithmetic. I'm going to try to group up as much as I can. So in this one, 3 times 0 is 0, add to the -6, and I have just -6. This one over here, 3 times 1 is 3, 3 plus a -6 is a -3. Right here, 3 times 2 is 6, 6 plus a -6 is 0. And then finally this one on the end, 3 times 3 is 9, and 9 plus a -6 will give us a +3. With this list of numbers, the 3's are going to cancel, and so my final answer is just -6. Some of the problems, I can't remember which ones, are going to ask you to list the 4 terms. That would be, for example, this row right here, -6 plus -3 plus 0 plus 3. And then the final total sum or answer would be this -6 at the end. So just realize that that's what they're looking for there. And then, let's take a look at one more. Just so you see the various types, example 3. We're going to start at k equals 0 goes to 4, and we're going to plug in the value into k squared minus 1. So as I look at this one right here, first term is going to be 0 squared minus 1. Second term is going to be 1 squared minus 1. Third term is going to be 2 squared minus 1. Third term is going to be 3 squared minus 1. And I gotta keep going till I get to 4. Fourth term is going to be 4 squared minus 1. So if I go down my list right now, plugging in the values, that's a -1. That's 0. Math teacher can't do math. 4 minus 1 is 3. 9 minus 1 is 8. 16 minus 1 is 15. So that's not too bad. We combine our numbers right here. 3 and 8 make 11. Take away 1 is 10. 10 plus 15 gives us a final answer of 25. And that's what we're looking at right there. So in a nutshell for sigma notation, what you need to realize is this. In the bottom spot, that letter is telling you where to plug in your numbers. You're going to plug in the starting value, in this case 0, to get your first term. You are then going to plug in consecutive integers. After 0 comes 1, after 1 comes 2, after 2 comes 3, and so on, until we get to our ending integer up at the top. Once we plug in that 4, we are done. You simplify your arithmetic for all of your rules till you get your final answer. This right here would be your list of terms. First term, second term. I know it's awkward because that's a 0 and I said first term, but oh wells. Third term and so on, and then the number at the end would be your final sum. And that is your sigma notation.